Let's evaluate this sigma notation expression. So this looks like a letter E. Sigma means we're adding a number of terms. We start with this expression 2n, but we replace n with the first number, which is at the bottom of the sigma notation, which is 0. So instead of writing 2n, we write 2 times 0. This here is our starting point. Then we add the same expression, the same term again, but instead of starting at 0, we increase it by 1. So now we have 2 times 1. We add another term, 2n, or 2 times the next number. What's after 1? We have a 2. And we keep repeating this pattern until we reach the last number, which is a 3, at the top of the sigma notation. So this sigma notation generates a bunch of terms that's being added. It's like a big machine. It's very quick. So this happens to be 0 plus 2 plus 4 plus 6, and these numbers are quite small. We have the answer 12. So this notation evaluates to be 12. Let's evaluate this sigma expression. We start at 2, so this is our term, 3x minus 2, and we replace x with 2. So the next term, we're going to plus the same expression, but instead of replacing 2, we're going to replace the next number, which is after 2, which is a 3. Now we keep repeating this process, and instead of adding a 3, we're going to place a 4. And then finally, we finish off with this number, which is a 5. And this is our ending number. We have 4 plus 7 plus 10 plus 13. 4 plus 7 is 11, plus 10 is 21. 21 plus 13 is 34. So this sigma notation evaluates to be 34. Let's try a challenging question. S2 equals 19 and S4 equals 50. We want to find S20, the sum of the first 20 terms in an arithmetic series. Now what's the formula for arithmetic series? The formula is here, and we know that S2 equals 19. So let's write S2, or 19, and here n is 2, 2 over 2, 2t1 plus n, which is 2, minus 1d. 2 divided by 2 is 1, so we're not going to bother writing this. We have 2t1 plus 2 minus 1 is simply 1. 1d is just d. So we have one equation and two different unknowns. Later in this course, you'll be learning something called systems of equations, so please don't worry about this question if you haven't learned about it already. However, you should be able to understand the algebra. Okay, so now let's focus on the second information here, S4 equals 50. So we have 50 is equals to n over 2, and n here is 4, 2t1 plus n, which happens to be 4, and minus 1d. So we just simplify. 50 is equals to 2 times 2t1 plus 3d. Let's use distribution. And now we have two equations and two unknowns. We should be able to solve for these two variables. So let's try substitution. Let's just try moving this term to the left. And so we get d is equals to 19 minus 2t1. and we'll substitute this d into here. 50 is equals to 4t1 plus 6d, which is 19 minus 2t1. We'll use some distribution here. 6 times 19 minus 12t1. So now we only have one unknown variable, which is called t1. We should be able to solve this. So we have 4t1 minus 12t1, which happens to be negative 8t1, which we can move over to the left-hand side as 8t1 is equals to 114 take away 50, which is 64. Divide both sides by 8. We have t1 is equals to 8. So there we have it. We worked hard and we finally found t1. And once we know what t1 is, d is equals to 19 minus 2 times t1, which happens to be 8. So the common difference d is 19 minus 16, which is equals to 3. We finally have our two unknown variables now known, so we can use the basic formula to find the sum of the first 20 terms. S20 is equals to n over 2, 2t1 plus n minus 1d, and n happens to be 20. So we have 20 over 2, 2 times t1, which happens to be 8, plus n, which is 20, minus 1d, and our d value is 3. We simplify. We have 19 times 3 is 57. So it's nice to have a calculator, and the final result of the question we're asking for is 730.